In this video, we'll talk about lines in space. In order to draw lines in space, we need either 2 points or we need 1 point and a direction, a direction of a vector. So let's say we have a point P naught of coordinates x naught, y naught, z naught, and a variable point P of coordinates x, y, z. And these points are on a line L that is actually parallel to a vector V that has the components A, B, C. So line L or vector L is parallel to vector V. So if we construct these vectors here, P naught P, it's a vector, OP, it's a vector, and OP naught, it's another vector, we can say that P naught P, it's equal to OP minus OP naught. So OP, it's equal to P naught P plus OP naught. Now OP, given that the origin is 0, 0, 0 and P is of coordinate x, y, z, the vector OP, let's label it as vector u, and this vector u naught, we can say that vector u, it's equal to P naught P, or let's start first with OP naught, u naught, the vector u naught plus P naught P, it's actually another vector that I'm going to write. It's actually the vector of line L, but because it's parallel to V, I'm going to say some constant t times vector V. So where t, it's a real number, but t, we can write also instead of real number, it's between infinity, positive infinity and negative infinity. So this form here, it's actually the vector form of the equation of a line in space. So if I know this information, like an initial point and a direction, I can find the equation of the line. But now u can be written using the fact that OP is vector u, we can write it as x, y, z equals u naught is x naught, y naught, z naught, so the vector in component form, plus t times, and the vector v, it's a, b, c. So we can say that x is equal to x naught plus ta, y is y naught plus tb, and z is z naught plus tc. This is the parametric form of the equation of the line L that passes through P naught P. So these two are important. So let's solve this equation. Find the parametric and vector form of the line passing through the point A of coordinates 1, 2, 3 and B of coordinates 1, negative 2, 2. So first of all, we can find the vector AB, which is equal to 1 minus 1, 0, negative 2 minus 2, negative 4, 2 minus 3, negative 1. So basically, from our formula, this would be our vector v. Let's pick one of the points, A, of coordinates 1, 2, 3. So then basically u naught, or we don't even have to do, or we do have u naught. The vector u naught is going to be of coordinates 1, 2, 3 like this. So if I want to write the vector form of the parametric line that is passing through AB, is going to be u naught plus t times v. So u is going to be 1, 2, 3 plus t times 0, -4, -1. So u is equal to 1, 2 minus 4t, 3 minus t. And this is the vector form. And the parametric form would be x, because u, it's x, y, z, right? So x, y, z, it's equal to 1, 2 minus 4t, 3 minus t. So x equals 1, y equals 2 minus 4t, z equals 3 minus t. This would be the parametric form of the equation of a line passing through A and B. So vector form and parametric form. Let's solve another problem. Find the equation of a line in parametric and vector form given the line passes through the point -1, -2, 3 and is going in the direction of v of coordinates 2, -3, 4. So let's say that it's passing through P naught. We know that if we use the formula R equals R naught plus TV, so XYZ equal to -1, -2, 3 plus T times 2, -3, 4, or XYZ equal to -1 plus 2t, -2 minus 3t, and 3 plus 4t. This is the vector form. And then if we equate each of them, x equals -1 plus 2t, y equals -2 minus 3t, and z equals 3 plus 4t, we found the parametric form. And let's do one more problem. Let's find the equation of a line in both parametric and vector form. If it passes through the origin, so through 0, 0, 0, and it's perpendicular to both u and v. So to find that vector that is perpendicular to both these, we would have to find the cross product of u and v. So I, j, k, and then we put the coordinates -1, 0, 1, 0, 2, 2, and that gives us I times, if we cross out, we get -2, minus j times, if we cross out the row and column of j, we get -2 again, and plus k times -2. Surprisingly, we got -2 on all of them. Just double checking here. So we get -2i plus 2j minus 2k. So this would be the direction. So we have the point, and the direction vector would be this one, -2, 2, -2. So we get r equals the 0, 0, 0 plus t times negative 2 to negative 2. So we get negative 2t, 2t, negative 2t. This is the vector form. And the parametric form is when instead of r we put x, y, z. So we equate them. So we get x equals negative 2t, y equals 2t, and z equals negative 2t, right? X, y, and z. And this would be the parametric form. Let's see one more problem. Find both the parametric and the vector equations of the L that passes through the point P0, coordinate 0, 0, 0, and is parallel to the line r equals 3, negative 2t, 5 plus 8t, and 7 minus 4t. So we start with this r, and we write it as 3, 5, 7 plus t times negative 2, 8, negative 4. This here is the direction vector that is parallel to our line and that we are going to use in our formula. So now the line that we want to get, it's r equals r naught plus tv. So our line, we can call it r1, is r0, which is 0, 0, 0, plus negative 2t, 8t, negative 4t. So it's actually negative 2t, 8t, and negative 4t. This is the vector form of the vector equation. And the parametric one would be x equals negative 2t, y equals 8t, and z equals negative 4t, because this r1 can be written xyz, and we just equated with this. So if we equate each position, we get the parametric equation of the line L that passes through the point P0. And let's solve one more problem. First, let's discuss a little bit the distance between a point and a line, right? So a point and a line, the distance would be this perpendicular. But in space, so the distance d between the point Q and the line R is d equals modulus, or the magnitude of the cross product v times pq over the magnitude of v, where p is any point on the line and v is a vector parallel to the line. So let's take a look at the problem we have here. Find the distance between the given point Q and the given line. So this given line, I'm going to write it as this form. So let's say r equals 7 to 4 plus t times 5, 1, negative 12. So P, it's any point on the line. So I'm going to say that P is 7 to 4. And I'm looking at the formula as well. So now having Q as 5, negative 2, 9, we can say that PQ, the vector, is equal to negative 2, negative 4, 5. V is the vector that we get from equating this r equals r naught plus tv. So the vector v is 5, 1, and negative 12. So D is equal to V cross product PQ over V. We have all the information, so we are ready to calculate. So let's calculate the V cross product PQ. That would be I, J, K, and we get PQ, V is 5, 1, negative 12, and PQ is negative 2, negative 4, 5. So I times what is left when we cross out, it's 5 minus 48 minus J times 25 minus 24 plus K times negative 20 plus 2. So we get negative 43I minus J minus 18K. This is the cross product, but I need, for my formula, I need the magnitude of that. So V cross product PQ in absolute value equals square root of 43 squared plus 1 plus 18 squared, or negative 18 squared, but that's positive. So we get square root of 2174. The magnitude of V is square root of 5 squared plus 1 squared plus negative 12 squared. So we get 25 plus 1 plus 144, which is 26 plus 144, it's square root of 170. So the distance D equals square root of 2174 over square root of 170, which equals square root of, if we divide them, we get square root of 1087 over 85, which is approximately 12.79 if we use 2 decimals after the decimal point.